So dear students, again welcome back for the fourth session of this solid state. So previously, based on the values of the three edge lengths, that is A, B and C, which are along x-axis, y-axis and then the z-axis, and then the three axial angles, that is alpha, beta and gamma, between y and z, z and x, and then x and y. So totally we are having the 7 types of crystal systems we are calling. It's the arrangement of which one? Lattice points, we are calling that as the crystal systems or the crystal lattice. So as if I have mentioned already, if it is cubic, A is equal to B is equal to C and alpha is equal to beta is equal to gamma, that is equal to 90 degree, that refers to the most symmetrical called as the cubic crystal system. If A not equal to B, B not equal to C and alpha not equal to beta not equal to gamma and all not equal to 90 degree, means it is just opposite with respect to the first one. It is called as the triclinic system. It's called as what? The triclinic crystal system. Now we will have the resemblance of first cubic with rhombohedral. So let us have first tetragonal and then the rhombohedral. So what means here? This is same and this is same. What's the meaning of that? All the angles are equal and all are equal to 90 degree, means they are mutually perpendicular to each other. But the thing is, the two edge lengths are same, but the third is different. If that be the case, it is called as the tetragonal. Whereas, if all are mutually perpendicular to each other, means all the axial angles are equal, but all sides are, all the edge lengths are not found to be same, means length not equal to breadth not equal to height, means it is called as what? Hedral, rhombohedral. Okay. Now we will have the special in the form of hexagonal. What's that hexagonal here? Two sides are equal, but not the third. And two angles, for example, alpha is equal to beta is equal to 90 degree, but gamma is equal to 120 degree, means it refers to the which one? The hexagonal nature. It refers to the which one? Hexagonal nature. Then I compare with the trigonal. What's that? It is a trigonal. It is also called as rhombohedral, I think. Sorry, orthorhombic. It is found to be the rhombohedral. Sorry, I make some correction here. It is not the rhombohedral comes here actually. Sorry, it is what hedral? Rhombohedral. So it is called as actually the all sides are not equal, means it refers to the orthorhombic. Orthorhombic. Okay. Rhombohedral means what? All sides are equal, no doubt. All sides are equal, means length is equal to breadth is equal to height. But the thing is, all the angles are also equal. Alpha is equal to beta is equal to gamma, but they are not mutually perpendicular to each other. Means they are not equal to 90 degree. If that be the case, it is called as what? Rhombohedral. Then the monoclinic. How that monoclinic is? All sides are not equal. A not equal to B not equal to C. But here the thing is, alpha is equal to gamma is equal to 90 degree, but beta is not equal to 90 degree, means two angles, that too with especially the, not the alternate angles, but one after the other, that is alpha is equal to gamma is equal to 90, but beta not equal to 90, that refers to the which one? Monoclinic. So these are the 7 different types of crystal systems that what we have suggested on the basis of the 6 parameters, in which the 3 are called as A, B, C, called as edge lengths, and alpha, beta, gamma are considered to be the axial angles. Okay. So in that totally we are having 14 3-dimensional arrangement, and those lattices are called as the Bravais lattices. Okay. That is, it may be the primitive, edge centered, body centered, and then the face centered. Okay. So that now we will discuss with respect to the types of unit cell. Types of which one? The unit cells. Okay. Types of unit cells. First, what is unit cell? It is the smallest repeating unit in the crystal lattice. It is the smallest repeating unit that can be repeated in the three-dimensional nature, or the set of lattice points which gets arranged in the three-dimensional network or the crystal lattice is called as what cell? Unit cell. Okay. Then how many types of unit cells we are expecting? The two are there. The first one is primitive, or it is also called as simple unit cell. Simple what cell? Unit cell. Then the second one is the centered unit cell. These are the two different types of which one? The unit cells. The first one is simple, or it is also called as primitive. This is the unit cell first. What's that? It is a unit cell in which the particles are only at the corners. Means we can find out the particles only at their corners. If that be the case, it is called as the primitive, or it is also called as the simple unit cell. So here, this is also a unit cell in which the particles are present. Particles are present not only at corners but also other positions in the given unit cell is referring as the centered unit cell. Means apart from that, the particles are situated at the corners. In addition to the corner particles, if the particles are present apart from that, I don't know where it is. So if that be the case, it is called as centered unit cell. So based on that, we are having the three different centered unit cells. One is body centered unit cell, face centered unit cell, and then the end centered unit cell. What cell? End centered unit cell. All are centered unit cell. Means the particles are not only at the corners but rest of the corners, or we can choose any part of the unit cell except which one? The corner particles are considered to be the what? Centered unit cell. The unit cell which contains the corner particles but also at the center of the crystal system, exactly at the center, means if that particular is chosen, he can have the symmetry in all the three-dimensional network. If that be the case, it is called as what centered? Body centered. So this is also the unit cell in which the particles are again at the which one? Corners. No doubt they are also at the corners, but also at the centers of the faces in the given what system? Crystal system. Then it is considered to be the which one? The face centered. Face means we are having the two dimensions, two axes are present. Apart from the corner particles, if it is at the center, then it is found to be the what? The end centered. Now it is which one? The end centered. What is the end centered here? Again it is a unit cell in which the particles are present at the corners. Corner particles along with the centers of only the opposite faces, not all the faces, only the opposite faces at the centers of the opposite faces, means it is called as end centered. Okay. So for example, let us assume this is one of the unit cell here. Okay. So here we can have the 8 corners. Cube means what? We are having the 8 corners. For example, 1, 2, 3, 4, 5, 6, 7, 8. We are having the 8 corners. If the particles are only at the corners, then it refers to the which one? The primitive, or it is also called as the simple unit cell. So then apart from that, we are having the centered unit cell. Means apart from the corner particles, if any particle is situated within that unit cell, that refers to the centered. And based on the presence of those particles with respect to the unit cell, we can have the 3 different types of centers called as body centered, face centers, and then the which one? The end centered. Apart from corners, if the particles is exactly at the center, for example, if I consider this part is found to be the what? The cube. At the center we are having the one particle, and that particle is called as the body centered. Okay. If this is the face, this particle is called as the face centered, because this is totally the face and this is called as what? The face centered. Okay. Then we are having the end centers. What is that end centers? This is one face and this is another face. They are the opposite faces. If the particles are present at the centers of this and this, means they are the opposite faces centers, then it is called as what centered? The end centered unit cells. So this is the general for all the 7 types of crystal systems. What are the 7 types of crystal systems that we have discussed based on the values of ABC and alpha, beta, gamma? Cubic, tetragonal, orthorhombic, hexagonal, rhombohedral, monoclinic, and then the triclinic. So then, in all the cases, we are having the common thing in all the cases is what? The simple. What is that simple or primitive? Where the particles only at the corners. Apart from the corner particles, if any particles is situated inside the unit cell, that refers to the centered unit cell. And that centered unit cells are of 3 types. What are those? Along with the corner particles, if it is exactly at the center of the whole crystal system or the unit cell, then it refers to the body centered. If it is at the centers of each phases, then it is called as phase centers. Suppose if it is present at the phases, centers of the only the opposite phases, then it refers to the which one? The end centered. Okay. But as per the syllabus, we have to concentrate only on the types of cubic unit cells. Only we have to concentrate on the types of cubic unit cells. Let's have the types of which one? Cubic unit cells. Because the most symmetrical crystal system or the unit cell that has been present is cubic, because cube is a 3-dimensional arrangement where it consists of how many corners? 8 corners, 6 faces with 12 edges. So let's draw that one. Types of the cubic unit cells. Cubic unit cells. So here as per the syllabus are with respect to the cubic unit cell. First, what is cube? Cube is a 3-dimensional arrangement system consisting of 8 corners, 6 faces, 8 corners, 6 faces, 12 edges, length is equal to breadth is equal to height. Indirectly we are calling that as A is equal to B is equal to C, and alpha is equal to beta is equal to gamma, and all are equal to which one? 90 degree. That is the 3-dimensional geometry. We are calling that as cube. What cube is? It is a 3-dimensional system consisting of how many corners? So let's have that first. I think this is a cube now. Okay. How many corners we are having? This is called as corner. 1, 2, 3, 4, 5, 6, 7, 8. Totally how many corners we are having? 8 corners. This is one face. This is called face. First phase, second phase, third phase, fourth phase, fifth phase, and then the sixth phase. Means how many phases we are having? 6 phases. This is called edge here. This is the edge. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Totally how many edges are there here? 12 edges. Means alpha is equal to, sorry, A is equal to B is equal to C. Means all the edge lengths are equal and all are mutually perpendicular. Means gamma alpha is equal to beta is equal to gamma is equal to what degree? 90 degree. Okay. So that is the cubic unit cell. Now, what are the various types of cubic cell that we have to know? So the first one is simple cubic unit cell. Simple cubic unit cell. Second one, we are having the body centered cubic unit cell. We are calling that as BCC unit cell. And third one is face centered cubic. We are calling that as FCC unit cell. What these are? The three types of which one? The cubic unit cells. So let us have the diagram related to this. This is the CUC. What is that CUC? Cubic unit cell. Where the particles are only at 8 corners, then it is consisting of simple cubic unit cell consisting of the particles only at the corners. Totally it consists of 9 lattice points. Let us call that as it is a cubic unit cell containing how many lattice points? 9 lattice points. Sorry, 8 lattice points. 8 lattice points in which 8 are at 8 corners of simple cube. They are at the centers of simple cube. Okay. What is body centered here? It is a cubic unit cell which consisting of or containing 9 lattice points. How many lattice points here? 9 lattice points in which 8 are at 8 corners and 1 at the center of the simple cube. SC means it is simple cube. If that be the case, it is called as what centered? Body centered. Similarly, what is face centered here? It is also the cubic unit cell. It is also the cubic unit cell which consisting of 14 lattice points. 14 lattice points in which 8 are at 8 corners and 6 are at centers of 6 faces. If this be the case, it is called as the face centered. Means simple cubic has 8 lattice points and those 8 lattice points are situated only at the corners. That is why it is called as simple cubic unit cell. Body centered has totally the 9 lattice points in which again 8 are at the corners and 1 exactly at the center of the simple cube, that is called as body centered. Suppose if the cubic unit cell consisting of totally the 14 lattice points. Among the 14 lattice points, the 8 are at the corners of the simple cube and 6 are at the centers of the how many faces? 6 faces. Okay. So let us have the drawing of that. I think I can draw here. Okay. So we are having a 3 cubes right now. Okay. Okay. So here this refers to, without dotted I am mentioned that as, it is the corner particles. It represents the what? Corner particles. Without blocking I have written there. So first this is called as SCC unit cell. SCC unit cell. Why? Because this refers to the which particles? Corner particles. How many corners we are having? 8. That is why this is a structure with respect to the simple cubic unit cell. Okay. Apart from that, if this is exactly at the center of this only, this is called as body centered particle. This particle is called as what? Body centered particle. That is why it is called as BCC unit cell. What cell it is? Body centered cubic unit cell. Means totally how many lattice points are there? 8 are at the corners and 1 exactly at the center of that cube. That is why it is called as what? Body centered. So let us have the third one. This is one face and this is at the center. This is face centered. 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 This dot represents the face centered particle. Which particle? Face centered particle. That is what is called as FCCUC. Totally how many lattice points we are observing here? I think it is 8 plus 6. 8 plus 6. Totally 14. Among the 14, 8 are present at the corners and 6 are at the, because I said this is one face, means this is called as face centered. Okay. So let us have this one. So I think first this is simple called as what? The simple cubic unit cell. Why? Because the particles are present only at the corners. Assume that 1, 2, 3, 4, 6, 7, 8. Totally 8 unit cell, means it is called as what cell? First the cubic unit cell. So apart from that, if the particle is present exactly at the center, exactly at the what? Center. At the center of this, if I remove this and put the particle exactly at the center, then that is called as what centered? Body centered. Means totally how many lattice points? 9. Among the 9, 8 are situated at the corners and 1 exactly at the center. I don't know the center because if I open up that and put at the center. Suppose if you assume that in way, if this is one cube, for example, it is a part of this one, this at the center is called as, or assume this total is one cube here, this is called as body centered. What center it is? Body centered. Now, this is one face, I think, corner, 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 corner we are having. This is called as a face centered. How many faces here? 1, 2, 3, 4, 5 and 6. Totally how many lattice points here? We can have the, how much? 6 plus 8, that is equal to 14. Or if I observe through this is one face, I think. This is corner, this is corner, this is corner, this is corner. But what is this? It is the face centered. Similarly, what is this? Face centered. 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 Totally how many face centers we are having? 6 face centered and 8 at the corners, and that refers to the which one? Face centered cubic what cell? Unit cell. Means based on the number of lattice points and then where these particles are situated, the cubic unit cells are of how many types? 3 types. The first one is simple cubic unit cell. The simple cubic unit cell is a cubic unit cell consisting of how many lattice points? 8 lattice points, in which the particles are present, means all the 8 particles are at the corners. Similarly, what is body centered cubic unit cell? It is also the cubic unit cell in which consisting of how many lattice points? 9 lattice points. Among the 9 lattice points, where the 8 are situated at the corners and 1 exactly at the center of this particular simple cube, that refers to the BCC, called as body centered cubic lattice or unit cell. Similarly, last one is what? Face-centered cubic unit cell. What is face-centered unit cell? It is also the cubic unit cell which consisting of totally how many lattice points? 14 lattice points. Among the 14 lattice points, in which 8 are again at the what? 8 are at the corners and 6 are at the centers of how many faces? 6 faces. That is why it is called as the face-centered cubic what cell? Unit cell. Okay. So this is about the different types of which one? The cubic unit cells. So that is simple cubic unit cell, body-centered cubic unit cell, and then the which one? The face-centered cubic unit cell. Okay. Next we will have the what is the contribution of each? Contribution of various particles. Contribution of various particles with respect to cubic unit cell. So now we will have the contributions of various particles with respect to cubic unit cell. With respect to what? Cubic unit cell. What is the contribution of various particles now? Let's have the first one. The first one refers to corner particle contribution. Then we will have the face-centered particle. Then we will have the third one is body-centered particle. Body-centered particle. And lastly we will have the edge-centered particle. Edge-centered particle. Okay. So here assume that this is a what particle? Corner particle. Here we are having the cube, here we are having the cube, or we are having the cube. Indirectly we are not saying that it is a cube, it is a what cell? The unit cell. Okay. So that I will show in this forum. Assume that this is one of the cube at the center. Okay. This cube is surrounded by, assume this part is one of the cube. Suppose if I put another cube like this, assume that it is not actually cube here. So here this corner, can I say that it is contributed to 2 unit cells? This is common to both. Common to both. Suppose if I put another cube here, it is shared by or it is contributed by 3. Suppose if this is the case, it is contributed by 4. Means if I take the 4 cubes, if I keep the 4 cubes, 1, 2, 3 and 4, 1 in the plane. This corner particle is contributed by 4 unit cells equally. Means this corner is common to 4 of these. Means what is the individual contribution? It is just only 1 by 4. So as if we mentioned that it is 4 unit cells are there here. If I put another 4 cubes, how much? 4 cubes. 4 plus 4. Where this is now? Can I say that it is visible or invisible if I put the 8 unit cells at a time? It is invisible. Means this is equally surrounded by 8 other unit cells. Means what's the contribution of that corner particle here? But it is just only 1 by 8th. Because any corner particle is shared by, equally shared by how much? 8 unit cells. Each corner particle is shared by how much? 8 unit cells. That is why its contribution is just only 1 by 8. Why? Because each corner particle Cp, which each corner particle is shared by 8 unit cells, because each corner particle is shared by how much unit cells? 8 unit cells. Hence the contribution is just only 1 by 8th, because it is not strictly to this. Here we are having 1 unit cell, here we are having the unit cell, here totally 4 are there, 4 plus 4. If I observe this particular unit cell, it is exactly at the center and it is not visible. But this particle is, or this corner particle is equally shared by how much unit cells? 8 unit cells. Therefore, the individual contribution is just only what? 1 by 8th. Face centered. So here, this is face, for example, and this is called as face centered. This is called as what? Face centered. If I put one cube here like this cannot touch with this here. Means there is no use of this. If I put another cube into this, above this, can I say that this face is visible or not visible here? It's not visible. Means this point is shared between 2 unit cells. Therefore, its individual contribution is just only 1 by 2. Suppose if I put the another cube here, this is no way concerned with respect to this face centered. Means this face centered particle is shared by how many unit cells? Only 2 unit cells. That is why its contribution is 1 by 2. Therefore, what is the contribution with respect to the face centered? It is just only 1 by 2. Why? Because each FC particle, FCP means, CP means it is called as corner particle. FC particle, FCP means it is face centered particle is shared by 2 unit cells. It is shared by how much? Only the 2 unit cells. Therefore, the individual contribution is just only what? 1 by 2. Let's have the body centered. So here what these are? They are the corner particles. Now, where the body center particle is? It is exactly at the center. I can't see here. I can't see. If I open this and at the center we are having the body centered particle. If I put this cube here, another cube here, it is no way concerned with respect to the body centered. If I put above or below or left or right, whatever it may be, this body centered particle doesn't touches with the other cubes or it may be the unit cell. Therefore, it's 100% contribution. Means its contribution is going to be the 1. Why? Because each body centered particle is not shared by any other unit cell, because as it is exactly at the center means it is no way in touch with respect to the neighboring unit cells. Therefore, the body center contribution is 100% or indirectly it is just only 1. Then we will have the edge centered. What is that edge center here? This is the edge of the cube, and this is called as edge centered particle. This is called as edge centered particle. Okay. If I put one cube here, can I say that this edge is common to these two? Okay. If I put another cube here, this is no way touch with this one, but it is touch with only the neighboring. So here 2, if I put another 2 here, means 4. How we have to arrange 4? 1 plus 1 cube like this and 1 plus 1 like this. If I make this one, this edge is common to 4 other unit cells. This edge is common to how much? 1, 2, 3 and 4. It is attached to 4 unit cells. Therefore, what is the individual contribution here? Just only 1 by 4. What is 1 by 4 here? It is a contribution with respect to the which one? Edge centered particle. Because each ECP, what is ECP here? Edge centered particle is shared by 4 unit cells. 4 what cells? Unit cells. Body centered particle is no way concerned with any other unit cells. Therefore, its contribution is 100%. 100% is nothing but 1 here. Each face centered particle is shared equally by 2 neighboring unit cells, or it is shared by 2 unit cells. Therefore, its contribution is actually 50%. 50% means it is called as 1 by 2. Each edge-centered particle is contributed by 4 other unit cells. Therefore, the individual contribution is just only 25%. 25% means it is 1 by 4. Whereas, the corner particle, each corner particle is equally shared with respect to 8 unit cells. Therefore, the individual contribution is 12.5%. It is 12.5% in terms of percentage. Here it is 50%, here it is 100%, here it is 25%. Okay? So here the corner particle is shared equally by how much? 8 unit cells. Therefore, the individual contribution is just only 12.5%. 12.5 means it is nothing but 1 by 8. So what this is? The contributions of various particles with respect to the cubic unit cell. If it is a corner particle, just you have to remember that value is what? 1 by 8. Why it is 1 by 8? Because the corner particle is shared by how much? 8 units. Therefore, the individual is just only 1 by 8. Face-centered particle is found to be the 1 by 2 because each face-centered particle is shared equally by 2 unit cells. Therefore, its contribution is 50% or it is nothing but 1 by 2. As body-centered particle doesn't touches with any of the neighboring unit cells, therefore its 100% contribution. Its contribution is 100% or its value is equal to what? 1. Whereas the edge-centered particle is contributed by 4 unit cells or 4 neighboring unit cells. If this be the case, its percentage, contribution for the percentage is going to be the 25%. In terms of ratio, we will mention that as 1 by 4. Okay, so this is how we are going to have the contribution of the various particles with respect to the cubic unit cell. If it is corner particle 1 by 8, if it is face centered 1 by 2, if it is body centered it is 1, whereas edge center means it is 1 by 4. Okay, so this is about the contribution with respect to the various unit cells of the what cell? Cubic unit cell. Now, in the next class, we will move on to the calculation of number of particles. Calculation of number of particles with respect to simple cubic lattice, body-centered cubic lattice and then the face-centered lattice. Okay, so that all we will discuss with respect to the next session of the solid state. Okay, so thank you very much.